Again, welcome everybody. Happy you're joining us today for a presentation on the Energy Standard Tools new functionality. One quick note, we're not joined by Chris Baker today. We're joined by Ryan Schwartz instead, but giving the same overview of that portion of the program. All right. So to start, this is what we'll be going through today. I'll go quickly through kind of the logistics of the presentation and note both our training site and how to pursue AIA credits for this. I'll give a quick 10 or so minute update on the recent updates to the 2020 or the 2030 program. And then I'll hand it over to Ryan for the majority of today, where he will walk through some of the new features available in the Energy Standard tool and the as designed tool. We'll leave some time at the end for
Pat, we just lost your audio.
Apologize for that. I appear to have disappeared for a second. I'm hoping that this is back for folks. I'll go back to sharing my screen. So we'll post these trainings on our website at b3mn.org. If you need AIA credit for this, please note your AIA number in the chat. We will just save all the chat and then send that along to the folks at AIA for credits. We'll keep non-presenters on mute and then use the Q&A to pick up questions as they come through. So this is the training website, and so this is where this will be posted. We also have slide decks from prior presentations if you're interested in going what our content is. Okay, so just in terms of background, those of you who are less familiar with the program, SB 2030 is a progressive energy and carbon reduction program. It's intended to customize, or is intended to fit Minnesota's climate and kind of available opportunities. It was modeled on the Architecture 2030 program initially, but customized, I'd say expanded to better fit Minnesota's buildings and to basically operate it as a state building requirement rather than a voluntary program. So we're looking at increasing reductions from a baseline. So the way both Architecture 2030 and SB 2030 are structured is looking at the average buildings in 2003 and taking increasing reductions from that average building. The reason why we used 2003 was it was the time of the first big assessment of how much energy buildings actually use in a survey called the CBEX, Commercial Buildings Energy Consumption Survey. Just a massive effort in 2003 to figure out how much energy buildings we're using. We use that still to this day as a baseline. We've moved that to a modeled baseline rather than actually at that survey data, but it's still that single point in time to take increasing reductions off of. And so the 2030 program takes increasing reductions from that baseline and changes the amount of reduction every 5 years. And so in 2010, We looked at a 60% reduction from that baseline as the requirement. In 2015, it moved to 70. In 2020, as of this year, we're now at 80% reduction from that baseline, and then moving on to 90% in 2025, in stepping towards net zero in 2030. This is just a piece of a larger network of programs. So SB 2030 is specifically the energy requirement that lives alongside the B3 guidelines, which is a broader scope sustainability guidelines program. And then buildings and operations hold on to that energy target, but also can use our B3 benchmarking program, which has about 8,000 public buildings in Minnesota and provides analytics and tracking of energy and water use. We have energy efficient operations, which can assist projects in streamlining their building operations and achieving some savings there. And we also have a post-occupancy evaluation process by which we survey buildings occupants on their on how well they're perceiving their buildings are achieving comfort. We've got two main tools project teams use as they go through the program, design and construction project teams. Those are the B3 guidelines tracking tool on the left and the energy standard tool on the right. I'm showing an older version of the energy standard tool on the right. Ryan's going to get into what that interface looks like currently. It looks a little bit different right now. These are the two main tools. The tracking tool, one on the left, picks up information related to lots of different guideline questions, and is intended to provide an area for teams to be able to document and verify that they're hitting the requirements of the program. Energy standard tool, I'm not going to spend much time on this because Ryan's going to be doing a deep dive, but this is the tool that basically does two things. It creates that 2003 baseline building so you can figure out what your target is, and also lets you input what your design factors are so that you can see how well you are performing relative to that target. So projects pass through the program. Early in design, projects would set their energy target. So you'd input your building's characteristics into this energy standard tool that creates that baseline and applies the reduction based on what year your schematic design starts. And you get an energy and a carbon target from that. This gets refined through schematic design, design development, and through the kind of final portion of the design. We call the construction documents phase final design. You'll input a energy model or document it through the as designed tool that we'll be showing today, and upload construction documents and related documentation, and we're reviewing that to grant it the compliance with the SB 2030 program. We also look at projects and operations where that energy standard continues and your building is tracked against that for 10 years of occupancy. And that's tracked, and that's used by integrating the tracking tool, the thing that the design and construction teams used as the project was moving through design and construction, alongside the B3 benchmarking program, where energy and water data will flow in and be compared to that energy standard. So project teams, we're at 80% reduction from that 2003 baseline, which is a pretty significant shift. And so to both hit those targets and to maintain cost effectiveness as is required by our authorizing legislation, we permit projects to hit those targets by looking at a hierarchy of efficiency and renewable energy options. And so if you're running up against the wall in terms of what options are available for projects, we can do an evaluation of seeing what measures should be applied on site and then what measures can we permit to be pursued with offsite measures. And so what we did was took the National Renewable Energy Lab classification of different types of net zero projects and where their energy is coming from, and applied that to this program. And essentially what this boils down to is projects need to look on site first to see what options are available to them, both in terms of energy efficiency and in terms of renewable. And then if they're the availability of those options on site exceeds a 12-year payback, that's when they can start looking off site. And we use 12-year payback as a cost test because that's what that is the proxy that we use for a more complicated utility style cost-effective evaluation. And so project teams would first look at efficiency measures and on-site renewable development. If they meant that's exceeds that cost-effective boundary, then they can look to other areas of their portfolio, and then barring that, they can look at procuring energy through renewable energy credits or RECs. So that's like a wind source or a renewable connect. It's a purchasing option. One note here is we do have a cost-effective test. This is only holding project teams to the on-site requirement that they can meet with cost-effective measures, and we define that cost-effectiveness at 12 years. It was 15 years for projects up into 2020. And again, that's a proxy for a more complicated assessment. We're also now holding renovations to the same standard as new construction, and that's in part because we have this ability to step through different options about on-site versus off-site compliance. There's other methods of compliance with the program. We've got a small building method, which is recently been updated, but it's we need to write up what that update is. So if you've got a project that you're looking to put through a small buildings path, it looks a little bit different now because it follows the same hierarchy, but we still have a prescriptive option available for those smaller projects. We've got an approach for partial mechanical upgrades. We've got an approach available for wastewater treatment facilities, and projects before 2020 had the option of looking at cost-effective testing for their projects. Right now, the cost-effective test has been baked into the path that most project teams take. The many project teams will take with the program. Okay, that is all my introduction includes. I'll pause here just for a minute. I know that was pretty fast, but I'm trying to get over to Ryan because I want to give him plenty of time to walk through his part of this. But I'll pause just for a second and see if there's any questions. Some of the AAA numbers have appeared in the chat. Please drop them in. Continue to drop them in if you're looking for AA credit for this. Okay, I will hand it over to Ryan.
All right, thanks, Pat. I'll share my screen here.
As you're loading up, there was a question from the chat about any progress on utility-specific emissions factors. That is a element of our 2020 updates. I would need to loop back to check into to where that is with the back end. It's a good question, Paul. I can follow up with that. One of the updates that we did in 2020 that I didn't cover today was we're permitting utility-specific emissions factors, and so that's giving folks in basically higher performing grids, lower carbon intense grids, credit for the work of the utility companies in lowering the carbon intensity. Okay.
All right. Very good. Thanks, Pat. This is Ryan Schwartz here with Willdan. So thank everybody for joining. As Pat mentioned, I'll be going through a quick presentation here for about the next 40 minutes. We'll leave some time at the end for some Q&A and to address any questions that do come up. But essentially just want to outline a number of the major updates that have been made to the tool recently. So we had a couple learning objectives here. Use of the tool to calculate that standard. We'll talk about how we're calculating that EUI and carbon emissions for a given building. One major change with the tool recently is the as designed approach. So we'll talk a little bit about that and then explain the difference between space types and space asset types, because that's kind of the key premise of how we're creating these models. So again, there's a number of slides within this slide deck here that go into the new updates. There are some that cover some information that is the same as what might have been displayed in previous trainings or versions of the tool. So I'll kind of jump over those, but can pick up any questions at the end. So just to start out with the SB 2030 tool in general, for those that have used it or those that haven't, it's a tool that is based on DO2 simulations developed by the Department of Energy. It's an hour-by-hour analysis tool, so runs 8760 schedules to account for every hour of the year, and takes into account the key main drivers of energy usage within a building, factoring in local weather, so accounting for temperature, taking into account building operations, process loads, schedules, equipment, lighting, everything that goes into the operation and use of a building. And then the third tier is kind of that actual physical building component that accounts for the building envelope, HVAC systems, glazing, fenestration, things of that nature. As I mentioned, it is an hour-by-hour energy modeling tool. So in addition to the things that I previously mentioned on the earlier slide there, it's accounting for outdoor weather conditions, the sun position, number of people in the building. So that's where the schedules come into play. Lighting controls, infiltration, ventilation, and the various envelope components as well. And as far as the HVAC goes, we're taking into account controls, schedules, set points, and efficiencies of the actual HVAC equipment. The tool is based on a series of default building characteristics. So the key premise of the tool is a simplified building approach. So we've tried to streamline the inputs that a user has to make within the tool. And so we started out with a lot of defaults relying on industry standards such as ASHRAE, ComNet, fundamentals, healthcare guidelines, ASHRAE 62.1 for ventilation requirements. And where those standards lacked or left blanks or gaps, we relied on kind of a previous project data set to help fill in some of those blanks. The tool is a web-based tool, so obviously there's nothing to download on your end, and it is available and can be used on tablets and through any major web browser that you'd like to use. Navigating the SB 2030 tool. So as Pat noted earlier, kind of there's the guidelines component where you can get access to your projects. The earlier slide that Pat showed did have some screenshots of the earlier version of the tool. That tool is still available out on the b3mn.org website as a goal setting version. The latest version would require you to have an actual project to gain access to it, just due to user restrictions and requirements there. But the old version is still available in a goal setting format on the website. The look of guidelines hasn't really changed. The energy standard tool is still available under the E1A credit under the respective phases of a project. The one major change right now is when you do click on a given phase of the E1 credit, it'll look a little bit different. The launch button will still be available, but you'll now see this manage analyses tab that will be available for use. This is the analysis manager, and moving forward, it's going to allow you to set active analyses for each phase. Really, the update in the tool now will allow you to have potentially multiple versions If you wanted to test something or test a change or a model input, you could have some additional analyses at your disposal to test those alternate conditions or measures, and be able to actually navigate and activate one of those given analyses to be the one that you'd like to move forward with and have actually apply to that phase for the credit. So when you click on that Manage Analyses button, it will bring up a window for that analysis manager where you'll be able to see what a given analysis is, when it was created, when it was last modified, and the phase that it is assigned to. So if it has a D, that'd be the design phase, PD would be the pre-design, and so on. There's several actions on the right side of that window. There's what looks like a pen or a pencil. That's where you would be able to rename that given analysis. There's a kind of a parallel line or arrow sequence. That's where you would have the ability to clone a given analysis. So for instance, if you wanted to test a difference in schedules, or you weren't quite sure how that might impact either the target or your design value, you could create a clone. Ultimately, that just creates a copy of that given phase, and then you could rename it to, as I did in this case, a test analyses. You could then access that, go into the tool, make adjustments, and see how the EUI energy standard was potentially modified, or your design value was modified. If at any time you didn't like that analysis, you could just simply use the trash can that is also available to you. On the left side, you'll see this active column and button. Essentially, that just indicates in the given phase that you've entered, that is the active analysis for that phase. So if the test analysis that I had created was the one I'd like to move forward with, you just simply click that button there, and that would change and make that test analysis the active one, and upload the information for the energy standard based on that. So hopefully this just gives some additional functionality for kind of those test cases and managing those moving forward. The core of the tool is pretty much the same as it previously was. Although there are several different icons. When you previously went into the tool, you would have gone to an intro page where you would have been able to select a checkbox for an as designed approach. That as designed approach is no longer a separate approach. It's one standard single path through the tool moving forward here. So when you go in and you access the tool, you'll get a screen that looks like this. You'll have 3 tabs at the top, which will be building, HVAC, and rating. And so similar to the previous process, at the building level, you'll define building characteristics. HVAC, if you were in that designed approach, you'd specify your proposed mechanical system and equipment. And then the rating tab is now where you will have the ability to add measures or strategies that will be applied to your design that you'd like to eventually calculate the EUI of your design and compare to that energy standard target. So it does look a little bit different upon initial entry, and that's just due to the single path forward for calculating the target and design results. The menu on the right side of the screen still is very similar to the previous version. It will give you the ability to enable detailed inputs, which is where you would have the user would have the ability to dive into schedules, set points, geometry, constructions, things of that nature in more detail. Like before, there are some color indications for status. Moving forward, red would mean something's in air or not resolved. Light gray means that it's not complete, so you need to finish some additional information before you could move forward. Dark gray would mean that it is complete and you could move forward, and then bold would indicate your current location. And these statuses really revolve around the three icons at the top of the screen. So currently my building icon is red, means that it's in air. That's just because nothing has been defined. Once I get things ironed out there, that red would go away. It is bold because that's currently where the screen is at, and you can just kind of track those as you move forward through the building definition. Similar to the indicators of color there are air messaging kind of icons and notes that are available to the user, just so that they can know if there is an issue or if something needs to be resolved. Oftentimes they're indicated by the little red triangle warning sign on the right side. If you hover over those, it will expand and kind of detail what is an issue. There's also red outlining and underlining, depending on what you're looking at. That will indicate that there is potentially an issue there. So you can see that this system one is outlined in red, and it's really due to the fact that nothing has been defined for that given system, and I have not identified any areas that are assigned to it. So once you resolve that, your red warnings would all go away. In addition to air messaging, there are helpful tool tips throughout the Energy Standard tool. Those are often indicated by text that is underlined. If you hover over that underlined text, it would bring open a little pop-up bubble that would help explain some additional information regarding either defaults or just in general what that information is. So for instance, this space asset areas text is underlined. If you hover over that, it would detail for you what a space asset area is. Building the model, even though the path is a little bit different, it's still very much the same as the previous as designed approach. But you'd start out by specifying your building type and area. Once you've picked that building type, essentially, it just sets default space asset areas for your use. You have the ability as a user to modify that going forward, but that's really just to kind of start the process. There are a number of building types that are available within the tool, and they're all listed here. There's, I think, 46 of them, so you should be able to account for pretty much any major building and construction that you might encounter, whether it's commercial, multifamily. There is an other building type if you had a building that was truly unique and you just wanted to build it up from the ground and apply space asset areas as you see fit. You could select that one, but most any other buildings that you encounter, you can select just that building type from your drop down, and it will preload kind of the typical space asset areas for that building. I mentioned you can create any unique building, and that is by what we call assigning space asset areas. Space asset areas are really the building blocks of the model that is used, and they really represent the basic programmatic functions within a given building. You can really, from the space asset area types that are available, really create any kind of custom building that you have. Our space asset types are based on and have definitions that are based on ASHRAE and ComNet and the other past project data that I previously mentioned. A lot of those details are editable, so that ability to edit those inputs gives a user ability to really customize that building. In addition to,
question popped up in the chat
yes.
that I think is to pick up right now. Can you have more than one building types for one project?
No, you can have, you'd make just one building type selection. But if you had a truly mixed use building, you would apply the space asset areas to accomplish kind of that mixed use function of a given building.
Great. Thanks.
Yep. And that question kind of goes along lines of the last bullet point here is that you can have additional space asset areas. This one here is really just outlining a multifamily building. If you had different mechanical systems in maybe one wing of the building versus another, you could have additional apartment space asset areas so that you could apply PTAX in one and maybe air source heat pumps in another. So that's just kind of one example where you could have the same space asset area, but just two instances of them within a model. And to expand on that, you could add apartments, you could add a classroom or an office space asset area to that multifamily building to kind of capture a mixed use component of that building. But yes, only one building type selection can be made. There is a key fundamental difference or point to make here about a space asset area. As I mentioned, it's meant to capture the broader programmatic function. And so a space asset area is different than a space type, which is often defined in the standards such as ASHRAE and such. And we're looking at a space asset area as a little broader piece of the building picture. And they're really, like I said, what's designed to define that building. When looking at a space asset area, they're assigned based on building type level characteristics to try and capture that program level of detail. For instance, classrooms, our classroom space asset area is really meant to cover kind of what you envision a classroom wing in a building. So it'd cover the classrooms themselves, but also the corridor area, potentially a small restroom, storage room, maybe a teacher admin office within that classroom wing. All of those areas, which are space types, would fall under our space asset area for a classroom. Now, there are some space asset areas that do need and do have a little more specific representation and do have some space type level characteristics to assign to them. For the most part, those are ones that have ventilation requirements, such as those following the AI healthcare guidelines, or spaces that have more unique lighting power densities or specific characteristics like that. So to expand on that, the next slide here kind of documents in the tool what areas would follow kind of the more specific space type approach. And as far as ventilation goes, it'd be in healthcare buildings, emergency departments, or laboratories or operatory spaces, even patient rooms. Ones that follow more of a specific space type approach just due to lighting power requirements would be apartments, laboratories, laundry rooms, locker rooms, conference areas, spaces like that. The final bullet point on this slide is really important, though. It's not an exact science to breaking out these space asset areas. You have the flexibility to modify inputs to really represent what you're looking at, but it is critical to not overthink them and to think about a broader program approach to it. You don't want to take every little small space. You want to look at that building in bigger chunks. And you got to think about it that the tool is simplified in looking at the whole model on a broader scale. You want to apply that same methodology to the takeoff and defining the spaces within that building. So just two quick examples here. For instance, an apartment area, as I mentioned, apartments are one that would follow kind of that more space type level definition. So if we're looking at the floor plate of a apartment level here, applying just a broad apartment area takeoff to it would be the incorrect approach. A better approach to that would be to split out the apartments on their own, and then that interior core space, which is really just corridor, elevator, maybe some mechanical space, could be split out into a common area saw. That'd be the approach to handle for an apartment. A second example would be in a hospital on a patient room wing where there's patient rooms around the perimeter. You wouldn't want to apply one whole patient room saw, because essentially that would overventilate that portion, or you would be applying a lot more ventilation to the model than you would typically need. So a better means would be to split out the individual patient rooms so they receive the correct ventilation that they would need, and then break out the other areas into more of a common area or any type of space asset area that would better address potentially office or stored things like that within that interior space. This slide just documents all the space types that are available. So again, based on the current list that's available, you should be able to really kind of capture the main building types that you would be trying to address. To just dive into a little bit more detail, again, when you pick that building type, it'll give you a preloaded list of space asset areas. You have the ability to add additional areas to a model. You can use the trash can to delete them if they are not applicable. And then there's means to address and kind of change the area allocations. By default, they come in with default percentages. You can easily scale them or click on the edit to really represent the building that you have. The final bullet point here just shows, kind of tying back to that earlier example, where you could have two apartment saws that really capture the two different wings within a building, so that you could represent two mechanical systems down the line. For each space asset area, if you click on edit, you have the ability to define the area, number of floors, defined if it's an apartment, number of units, and then the arrangement, which really just tries to help define kind of the amount of envelope and exterior walls and ground and roof conduction values within the tool. One new feature that is available is this Help Me Choose feature. So if you add a saw right next to the space asset line, there is a series of triple dots. If you click on that, you'll get this Help Me Choose button, and it'll pop open a window where you can scroll down through the available space asset areas, and it will give you just a brief description of what is all included. So this is a very helpful reference for when trying to determine, is it an area that has more of a building level approach, or is it more specific to a given space type? So that information is available to you. If you just click on the name in that list, you'll get an update here of what it details. And then if you hit select, it will pull it into that field for your use. Like before, you always had the ability to modify details. Won't go into too much here, other than to note that by checking that Enable Additional Details button on the menu, you'll have the ability to further define schedules, geometry, space, temperature set points, ventilation, and things of that nature. Not much changed, at least in the initial operation details. One latest change is as far as the schedule goes. The core premise of the schedule is still the same. So you'd have the ability to define the daily use in terms of none, partial, or full. What we've done now is expand the ability to separate schedules for the loads such as people, lighting, and equipment, and split them from the fans. So now as a user, you'll be able to define kind of the core hours in a full day. This input is going to drive the loads component. There is a separate input for fan hours. So there you can plug in how those fans will operate, which gives the ability for buildings where there might be people only there for a portion of the day, but maybe the fans are on 24/7. You have that ability to make that edit here. There's also expanded ability as far as defining the partial day, where you can define kind of the core hours of that partial day, and also input a fraction to define kind of the load or the peak component to say on a partial day, I have 25% of my max full day value. So some additional functionality is there for you as far as defining schedules. The mechanical set points and ventilation, all of that is the same as before. So I'm going to kind of quick go through that. Envelope and constructions, not much has changed there as well. Defining geometry, that is still one too. I guess just to highlight there, the approach is still the same. The couple points are, again, kind of like breaking out the saws, treated at a high level, and there's no need to break out every little corner or bump out of a building. And because you're defining the geometry at the saw level, you need to think about it on a little grander or broader scale as well. So I'm going to just move on to the HVAC system, and just the screen or image here highlights kind of my building has been fully defined. It goes to dark gray. Now I'm in the HVAC system, and it's incomplete because I got some work to do here. One change that you'll see is we've introduced this use a template feature. So if you're coming in, especially earlier in pre-design, you could click this use a template, and we have a predefined list of some typical systems that could be built up for your use, such as a packaged single zone with DX cooling and gas furnace, or a air source heat pump. You have the ability to just click use a template. It will build up all of the mechanical systems. It will apply the respective plant equipment that it is needed, and it's kind of a streamlined approach. So it could be used especially earlier in that pre-design modeling that you might do. If you click on the just define my own, you have the ability to define your own system, specifying everything at that central plant level, as well as the HVAC system. So as far as the central plant goes, now moving forward, you have the ability to specify the fuel type or for your domestic or service hot water. You can define your central plant heating and cooling equipment, whether it's a boiler, gas boiler, or air-cooled chiller, water-cooled chiller. This is where you would define your district heating and district cooling information as well. So based on a selection of district heating and cooling here, that district component will be accounted for within the target that will be calculated as you move forward through the tool. Once you get past, or I guess the other piece in the central plant equipment is a dedicated outside air system. You have the ability to select what those heating and cooling sources are as well. Once you've defined your central plant equipment, you would specify your HVAC systems, specifying the conditioning type, heated, cooling, what that type is, whether it's a VAV system, packaged single zone, VRF, that would be defined at that system type. And then you would apply your heating and cooling sources, whether it's connected to that central plant or if it's a gas furnace, electric resistance, or potentially on the cooling side, DX cooling. So those pieces of it are very similar to kind of the process through the previous as designed approach as far as breaking up your central plant, your mechanical systems. As you go through the tool, if all you were concerned about was calculating the target value, you would get everything in the HVAC section defined and then move forward to our rating tab. Once you get to the rating tab, it's going to automatically calculate that new target value for you. And the rating tab now is very similar to the results tab in the previous tool, but it's got a new look, a widget look, as we kind of call it. But at the top of the screen, you're going to get a bar chart that will detail your target value in both EUI and the carbon equivalent intensity value. So the T is what will be the target and what you're trying to get your design to achieve. The D will be your design value. So if you are using this as a as design tool and you apply strategies within it, that D will represent where your current design energy use intensity or carbon emission value is at. The reference is really just that reference model that's used to calculate where the target should be. So like I said, if you're coming in here for just the target, this is as far as you would need to go. However, you do have the ability to use it as a as design tool and really capture the strategies that you are applying in your design by adding additional strategies. The previous version of the as design tool was fairly clunky and you had to add just one measure at a time. We've streamlined this so you can just click this add button and you'll be able to add multiple measures all in one go to really simplify that means. There are a number of other icons within this screen. There's a mechanical viewer that will detail what your system is. There's some helpful visualizations that you can access to really get a picture of other results pertaining to your model. And then you can configure widgets. By default, this is what the screen will look like, but there are other widgets that show savings potential and other values that are available to a given user. There is one key feature here that I skipped over, but I wanted to highlight. In the top right corner of the screen, you will see the name of your project and analysis. If you click on that, you'll be able to return to guidelines. So when you get to this point and you got your design value or your target, you can just simply click on this drop down and click return, and you'll get back to the guidelines window, which will be very helpful. As I mentioned, if you click the add button to add multiple strategies, you'll come into a view like this where you'll be able to click through various tabs, mechanical, architectural, everything through service water heating. And to add strategies, you just switch this little toggle that is on the right. If it's a light gray and white, it means that that strategy is not applied. Anything with the shaded toggle means that that strategy is applied to your design bundle. And it's nice because you can just quickly click through the given tabs and view the different measure lists and apply all the applicable strategies in one go. Once you're done, you can either click on the done button in the middle of the screen or click on the strategy selection done. Both will bring you back to the main screen. It is nice because all the strategies are continually calculating. So once you'd hit done, you'd come back to potentially this summary view where you'll see individual savings of those individual measures. All of those will update for you based on the characteristics that you've given them. You can switch between the summary view, which will show results, and this key parameters view, which will show you essentially this same view where you can modify what the R value is of your wall, modify your glazing characteristics, or modify your efficiencies of your mechanical system. There are incremental costs in there for new construction buildings, so those are costs above and beyond code. You can click on them to modify those costs if you like. In this view, there's also a trash can. You can delete that strategy from your design if you had accidentally added it in error. Again, there is this key parameters tab. So for each strategy, you can modify what that key input is. You can also click on the triple dots next to that strategy name. It will provide you some additional strategy information describing what it is. There's a filter button as well. If you click on a given strategy name, it'll bring in this slide in pane where everything's kind of in one window for you. It'll have those key parameters. You can modify the value here as well. You can add notes if you'd like to document anything for that strategy. If you click on the savings tab, it would bring you to a screen that captures the savings level for that given strategy. So there's multiple ways to modify the parameters and also view the savings of a given strategy. At the very end, once you've applied strategies, you just simply click the calculate button. That will take and run a simulation that will account for all the interactive or interactions between those strategies to calculate that design value, which would then show up in your bar charts above. You as a user can gain access to the input and simulation files that are used, and that would be done by clicking on the triple dots that are either available in the table for the EUI, or the similar triple dots would appear if you hovered over the carbon emissions. You would then be able to get the sim files for your design and or the target value as well, if that was of interest. There is some additional capability to modify the widgets there, but as we're approaching kind of the end of our hour here, I'll leave those. It's pretty self-explanatory to kind of click through and modify those widgets so that you can gain access to some additional reporting. The measures, not much has changed there. The measures for each of the various tabs is still consistent as the previous as designed tool. The ability to select them all in one is really the major benefit of the new user interface. One thing that will be coming to is solar PV, since obviously with the energy conservation measures, there still might be some gap. We're looking at adding in a solar PV component that would be available for you to select as well, so that you can capture that in the design value. So there are a few slides that are out on the Net Energy Optimizer How It Works website. If you're looking for some additional information, that's a good point to turn. There is a widget value or a widget that's available if you run into any issues that you could report any questions or things that do come up. So with that, I guess that was a quick run through of those updates. I'll turn it back to Pat to kind of address if there was any Q&A comments that came in.
Yeah, we've got a couple. There was a question about addressing air CFM per square foot versus ACH.
Yes.
That my understanding of that is the tool actually doesn't just convert between the two. It actually does. It runs them separately. So if you identify you have a certain occupant density, it's multiplying that by the number of CFM you have per person. It's multiplying the number of CFM you've identified per square foot by the identified square footage. And it's also taking the volume and running the ACH on that. Is that accurate?
So to clarify that, if you have the ability to define one or the other, you can define the ventilation for a given space based on air changes, or you can define it based on flow. So if you had the flow characteristics, which would come into default for most of the space asset areas that you would select, you'd get an outside air per person and a per CFM value that would define the ventilation. Some of the spaces, such as laboratories or operatory rooms with air change requirements, those ones would come through by default as an air change requirement, either occupied and unoccupied definition. You can toggle that switch between the two if you want to define it on a different approach, but it's really one or the other for a given space asset area.
There was another question about whether project teams need to upload their own energy model, trace, ISVE, et cetera. So just to clarify, this as designed functionality, the ability for you to input your project parameters, your design parameters into the tool is one available method to prove out that you're hitting your 2030 target. We've done some effort to also make that more streamlined for finding that on-site target, because there is the costing piece here done with the payback years. But if a project team feels more comfortable or wants to use ISVE or wants to use a trace model, that's still acceptable from our program. It looks a little different because it's not embedded in the tool, but we don't require this this functionality to be used to document your design. So this is an option, but it's not you're not required to put it into this software. We think it's streamlined with the stepping through of the program, but we're still accepting other design simulation. There's another question about whether the hosted, stacked, adjacent classifications are gone for the space asset areas.
Nope, those are all still there. You would be defining those at that initial space asset area identifier. And again, you still have the 3 adjacent, grade, stacked, or hosted for your selection.
There was a question that came in the Q&A, whether that you can look at breakdowns of energy consumption, for example, DHW versus heating versus cooling. What kind of granularity is visible from the end-use breakout? Yeah,
so the end-use breakdown will capture a breakdown of heating, cooling, fans, lighting, equipment, service water, heating. So in the visualizations, I'll just show you where you can access that real quick here. There's that visualizations icon that is available for your use. If you click on there, you can access a series of charts, one of which would be energy use by end use. That would give you an EUI breakdown for each of the major core end uses within this simulation that are broken out. Heating is broken out from service water heating, so you could see a difference in, if both were gas, you could see which one's contributing to which. So that is available in that visualizations icon right next to the calculate button.
Great. Last question that I see currently is what analysis needs to be done by what phase. So we, in the tracking tool, there's options to run this model at pre-design design, which is the schematic design development, and then final design, which is the construction documents phase. The expectation is that the pre-design version of this would be when you know what the program of the building is, that this gives you some idea of what the energy target is going to be, understanding that as the design develops, that may shift as the design of the project shifts, but it gives that first initial understanding about what level of performance is going to be needed, and then also what level of efficiency measures and potential renewable development is going to need to take place as part of that to bring this to that 80% threshold. At the design phase, that's so that is just a target setting. We don't actually review that at that design phase or at the pre-design phase. At the design phase, this is an early phase model where you've got a good idea of your program. You've got some idea of what measures are being input in this. And we think that using a tool like this allows you to pretty quickly throw in those kind of levels of performance to see where you are with what you're applying to the design with where you are with the target. And then we can come in and look at that. That's also the phase at which a discussion about setting an on-site target. If you're looking to access off-site resources to hit your target, that's when that would begin. And that's more of a conversation that would be booted up between us and CEE about what strategies are being evaluated. And then a final design, we're looking at construction documents against the inputs of the tool to make sure that what is going into the design simulation matches what's going into the construction documents, which matches what's going into this tool. So that looks a little bit different whether you're using this tool to both set your target and do your design documentation, or if you're using another program to do your design documentation. But we're still looking for those 3 things to match. We're looking for the design to match the construction documents, the construction documents match the design simulation to match the energy standard tool inputs. And I hope that answers your question. I understand we're 1 minute over, so I wanted to just take 1 second to note if there's any last questions before we wrap up. I see none remaining. I'd like to thank everybody for their time this morning. And you can always reach out to me, patsmith@umn.edu, if there's any questions on program participation or any other issues related to the SB 2030 or B3 programs. All right, with that, I'll wrap it up. Thank you so much, Ryan, and all of our attendees.
I know.
Have a good week, everybody.